Okay, so our next step in square roots and the quadratic formula and radicals is to try and start to solve some of these. So we did this in our last unit right towards the end. And now we're going to kind of take it up a notch. So we're going to start by solving these, starting with the less complex to the more complex, and just going to be careful with finding our solutions. So for this first one, I have to solve for x. I have to think, well, the x is under the square root. So if I need to get rid of that square root so I can get to the x, I need to be able to square it. Okay, what you do to one side, you do to both sides. So when you square a square root, they undo each other because they're inverse operations. Okay, so we are left with x minus 3, and then on this side, I get 25. And then to solve for x, I'm just going to simply add the 3 over, and then we find our solution, x is equal to 28. Trying kind of another one. It's very similar to that, same idea. So the x is under the square root. So in order to get to the x, I need to think I have to undo the square root, or I have to take the inverse of the square root, which is the squaring function. If I square a square root, they undo each other, and I'm left with 2x minus 1. And on this side, I get 16. And now we're just solving our equation for x. I'm going to add over 1. I have 2x is equal to 17. And then divide through by 2. It's okay. You get a fraction. You get 17 halves. Or you could put it in its decimal equivalents if you'd like. Okay. Taking it a step harder this time. So now, yes, the x is still under the square root. It's just this time I see that there's a 3 in front of the square root. I also see that there is a 4 on the outside of the square root. So I want to kind of think orders of operations, what would I want to do first? I'd want to try and get everything away from the square root first before I square it. So first I'd probably want to add over this 4. So I have 3 square roots of x is equal to 24. Okay, again, get rid of everything we can before we square it. So I'm going to divide through by 3. And so now I have the square root of x is equal to 8. And now I can get rid of the square root by squaring each side. And now I have x is equal to 64. So this one you had to be careful. Orders of operations, kind of think move everything away from the square root first. Okay, same idea on letter D. Want to move everything away first. So again, we're going to start by adding the 4 over. Okay, it's kind of like a reverse order of operations. And over here, I get 40. Again, kind of like what we did in letter C, I'm going to divide through each side by 5. So now I'm left with the square root of 3x minus 2. And on this side, I'm going to have 8. Now again, I want to get rid of the square root because the x is under the square root. So here's where I would think undo the square root by squaring each side. And I'm left with 3x minus 2 is equal to 64. From there, if I add over the 2, I have 3x is equal to 66. And if we divide by 3, I'm going to be left with x equaling 22. So we just have to be careful, watch your orders of operations, step at a time to solve. Okay, we have another one here. Maybe it just looks a little uglier because we have a fraction. It's the same process. Step number 1, I'd want to think divide each side through by 3. So I'm left with the square root of x divided by 2, and on this side we have 5. And then from here I need to think square each side so I can get to the x, which is under the square root. So now I'm left with x divided by 2, and on this side I get 25. And now in order to get x, I want to think multiply each side by 2. If I multiply this side by 2, the 2's reduce out, so I'm left with x. And if I multiply this by 2, I'm going to get my final answer of 50. Okay. So a more complicated situation is going to come when we have a square root expression is equal to a linear expression. So that is going to show us, or we're going to see that, I should say, in our next exercise. So we have the systems of equations shown below, and it says we're going to solve this system graphically using the grid to the right. So plotting this out, we can do this by transformations if we want. I have the square root of x plus 3, so that's a shift to the left. of the square root function by 3 units. So I'm going to go 1, 2, 3. I know it initially started at 0, 0, and then it went over 1 up 1, and then remember it goes over 4, so I got 1, 2, 3, 4 up 2, and then it went over 9, so there's 4, 5, 6, 7, 8, 9 up 3. Okay, you could use your calculator to help do this as well, but if you know your functions and you know the transformations, sometimes you don't even need your calculator. Okay. Same thing with this y equals x plus 1. So this is an equation of a line, slope of 1 shifted up 1 unit. So your y-intercept is at 1, and you have a slope of 1, meaning you go up 1, over 1, up 1, over 1. You could also go down 1, back 1. And so now you would have your equation of your line. Okay, make sure we have arrows and labels. And that's our equation. Now, if we were to solve this graphically, your solution is where they intersect. So that's your solution. And we can see their point of intersection is located at 2, 1. Okay, what about algebraically? Okay, so if we're doing this algebraically, we see they're both equal to y. We always say if things are equal, set them equal. So the square root of x plus 3 is equal to x plus 1. All right, so just like we did on the front, we want to think to ourselves, how do I get the x? Well, I have an x trapped under a square root. So I want to think square the square root, and that will cancel out your square root. Okay, so I have left x plus 3. And now on this side, we have to expand. Keep in mind, that's really going to look like x plus 1 times x plus 1. So you're going to be foiling, or you're going to be doing that box method to simplify this. So our firsts would get us x squared. Outside get plus 1x, inside gets plus 1x, so that's a plus 2x, and our last terms would get us a plus 1. Okay, so what do? We want to pull everything over to one side of the equation so we can set it equal to 0 and factor. So I'm going to move everything to this side, make this side my 0. Okay, so I have x squared, so I'm going to subtract over an x, which is going to leave me with 1x. I'm going to subtract over the 3, so 1 minus 3 is going to leave me with negative 2. All right, so now we're in a situation where we have to factor. I need numbers that are going to multiply to be negative 2 and add to be a positive 1. Okay, so that's going to leave us with positive 2 and negative 1. And then if we set these equal to 0 and solve, I'm going to get x equaling negative 2, or I'm going to get x equaling 1. And now at the top it just said we are only solving for the x value. So we're just going to stop right here. But this should raise a red flag. Okay, there should be an issue here that we're having. Well, number one, the first issue is the fact that I had a dyslexic moment back here. This is not your right answer. The right answer should have been 1, 2. I apologize, over 1 up 2. And now the second issue you're going to have is, how come we only got 1 point of intersection up here, and I got 2 points down here? And if I look at negative 2, if I go around the graph on negative 2, there's definitely no intersection. Okay, so there's something going on here. So why, if I solve it graphically, I get 1 point of intersection, but when I do this algebraically, I get 2. Okay, so we have to think to ourselves. Okay, so algebraically, we get 2 answers. Graphically, we get 1 answer. We're trying to figure out now which one is right. Well, let's try the one that we didn't get. So if I tried that negative 2, think about what happens in the square root. If I were to just plug that negative 2 into our square root function, get negative 2 plus 3. Negative 2 plus 3 gets me the square root of negative 1. Okay, that does not work. That does not exist, number 1. But let's just say it did. If it did, I should be able to plug that into my linear equation, which was x plus 1, so negative 2 plus 1. And if I solve that, I get negative 1. Well, that's not really going to be the same, except for, again, I'm having errors all over the place. Let's try this again. Negative 2 plus 3 would give me the square root of 1, and the square root of 1 is 1. Let's try that. that gives you the coordinate -2, 1. Over here, I get +1, which if I put that together, I get -2. And I'm looking at this going, okay, these are not the same. That's an issue. Okay, so if that's the case, and you see how we're producing different answers, -2, 1, -2, -1, not the same, then that means this back here is not a solution. And so what you have to do is you have to reject that. Cannot work, does not work. I get two different solutions back here when I plug this in. Okay, so with that being said, let's see if we could find these answers, okay, and see if we find what they're known as to be extraneous solutions. And how you know if you have an extraneous solution is kind of like what we did. You plug it back in and you check to see, do I have an error? Okay, so let's try number 4. And you can always check this graphically too, and then support it algebraically. So it says we're going to find the solution of each of the following, and be sure to check our work and reject any extraneous roots. So number 1, we're going to solve this like we did at the beginning. We're going to square each side to get rid of the square root. So now I have 2x minus 3, and over here, remember I have x minus 3, x minus 3. So I have to expand that out. So I get x squared, outside's -3, inside's -3x, so that gets me a -6x. And my last is going to give me a +9. Okay, so again, like we did in that last problem, bring everything over to one side of the equation and set it equal to 0. So I have a -6x minus 2x, so I have a -8x. Over here I have a +9. I'm going to have to add over the 3. So +9 plus 3, that gets me plus 12. Okay, now from here we want to factor. So I need something that multiplies to be 12 and adds to be -8. So how about a -6 and a -2? Okay, so that gets me solutions of x equaling 6 and x equaling 2. So now what would I do? Now what I would have to do is I would have to plug this in back to that original equation that we had up here and see, is that going to work? Am I going to get the same answer for both? Okay, so let's try this first one with 6. So I would have the square root of 2 times 6 minus 3, and we're seeing, is that going to be equal to 6 minus 3? Okay, so 2 times 6 is 12. 12 minus 3, I get 9. Okay, and then over here, I have 6 minus 3. So 6 minus 3, I get 3. So this gives me, so the square root of 9 is 3 equals 3. That actually looks like that's okay. Okay, so what is that telling me? That tells me that this is a good answer. Let's try 2. Okay, we do the same thing. Square root of 2 times 2 minus 3. And then we're going to test and see, how about 2 minus 3? Does it equal now? So 2 times 2 is 4. Square root of 4 minus 3. So 4 minus 3, we get 1, so I get the square root of 1 on this side. Okay, 2 minus 3, I get a -1. Square root of 1 is 1. So -1 does not equal +1, so that can't work. So what does that mean? That means that's your extraneous root, and we would get rid of that. So you only have one solution for this. Okay, let's try letter B. Same idea. Now we just, again, have to be careful with how we solve. Step number 1, we want to get everything away from the square root. So I'm going to add over that 2. So we have 2x plus 2. And on this side, I have the square root of x plus 6. Okay. So x is trapped under the square root. So I need to think square each side to get rid of the square root. Keep in mind what this left side turns out to be. 2x plus 2 times 2x plus 2. On this side, squaring the square root eliminates the square root, and we're left with x plus 6. Okay, so now we have to, again, do a little bit of foiling here. So 2x times 2x, I get 4x. Outside, I would get, I'm sorry, 4x squared. Outside, I would get 4x. Inside, I would get 4x, so that's a total of 8x. 2 times 2, I get 4. Okay, now, just like we've done in the other problems, we want to bring everything over to one side of the equation. So again, I'm going to move this all over here. So 4x squared. Now I have to subtract an x, so that's going to leave me with plus 7x. And I have to subtract the 6, that gets me negative 2. And we're going to factor. Now remember, this is kind of the harder trinomial factoring, where we have to go 4 times negative 2 first. So it has to multiply to be a negative 8, and it has to add to be 7. Okay, so factors here about 1 and 8. The sign of the middle term is positive, so that goes with my larger factor, which means 1 has to be negative. Okay, so we're going to copy your first term, split that 7 up into our negative x and our positive 8x, and then copy your last term, and now we have to factor by grouping. So if we factor by grouping here, this is going to leave me with, I pull out my common factors, I can pull out 4x, I would have left x, oops, sorry, nope, let me try it again. I could pull out an x, that would leave me here with 4x minus 1. Over here, I could factor out a positive 2, and again, that's going to leave me with 4x minus 1. Okay, so the factors that we have, I have one factor of x plus 2, I have one factor of 4x minus 1, and now we can solve, and we can see here x would equal negative 2, and x would equal 1/4. Okay, so now our job is to test and see what happens. Okay, so with the 2, with that negative 2, if we plug this in, so I would have 2 times negative 2, and I would have the square root of negative 2 plus 6 minus 2. So this over here, I get a negative 4, negative 2 plus 6, that's going to get me a positive 4, so I get the square root of 4 minus 2. Okay, so the square root of 4 is 2, and 2 minus 2, I get 0, so what I'm finding here, I have to reject this. That's no good, I cannot keep that one. Okay, let's try our 1/4. So I would have 2 times 1/4. Now we're going to see, is that equal to the square root of 1/4 plus 6, and then from here we want to subtract 2. Okay, so 2 times 1/4, or I could take 2 divided by 4, that's going to leave us with 0.5. And over here, in all honesty, I'd probably just grab your calculator to plug in all of this stuff, but this would give me 6.25, right? So I get the square root of 6.25 minus 2. And when you plug that in your calculator and you check that out, this square root of 6.25 actually gets you 2.5. Subtract out the 2, and you get this. That's good. That's a good check. That means 1/4 is actually going to be your answer. Okay, and again, you can check these graphically, but this would be the way to check it and support it algebraically. We will practice more of these in class. As always, bring your questions to class, and I hope you guys have a great day.